We have a strong acid and a strong base. Okay, recorded na. When we have a strong acid and a strong base, it will dissociate or it will ionize completely. Meaning, uh, it will ionize completely into charged particles like we have here a cation and an ion or positive and negative. Now, we have an arrow, a single-headed arrow because it's a strong acid. Now, if we have similar to similar to strong bases also, it will dissociate completely or it will ionize completely. Now if we have a weak bases and weak acids, that's the time that we will have a double-headed arrow, and then the calculation there will be more complex than when we have a stronger acid and a strong base, because we know that if we have a strong acid, uh if we have a strong acid is we will just okay. If we have a strong acid and a strong base, the calculation is much easier. But if we have a weak base or weak acid plus H2O, then we have a double-headed arrow there, meaning H plus plus OH minus. So the product is the same, but notice that it's a double-headed arrow, meaning the forward and the reverse reaction will be equal. So there will be a forward and reverse reaction if we have a weak base and then if we have a weak acids. Now the calculation there will be more complex, so we will have a Ka. Now Ka is again the product over reactant, which is H plus, and then we have the OH minus over the HA. Now, also if we have weak acids and weak bases, then we will have a conjugate acids, then we will also have a conjugate bases. Okay. Now, what will happen if we have a large Ka? It means that what will happen if we will have a large Ka? Remember when we were talking about equilibrium on the previous chapter, if we have a large Kc, what will happen?
Mas dako ang products, ma'am?
Okay, so that's for generic one. Now, the same thing also happen here. If we have Ka, because Kc is ano siya na more general. Now, if we have Ka, it's more on the acids lang. Now, if we have large Ka, then it means that the product is more favored. Okay, there will be a lot of concentration of your hydronium ion H plus or H3O plus, di ba? Mo man na siya, H3O plus. Now, don't be confused with H plus and H3O plus. So, they are used, mo ginagamit na siya equally bitaw. So, kung when you talk about H3O plus, then you're just talking about H plus ra gihapon. Okay, same ra class ha. No, we have H plus or H3O plus. Now, we have here Ka. If we have a larger Ka, then we will have more products. Okay, remember this one. And then also, it will become more acidic or more basic.
Acidic, ma'am.
Yes, it will become more acidic because there will be a lot of concentration of your.
Acids.
Okay. Uh, Yes. And then also, what will happen if we have if we have a large Ke, what will happen to your pH?
Gamay, ma'am.
pH will become.
Less than 7.
Okay, yes, pH is less than 7 because it's more acidic, 'di ba? Acids in a pH scale, acids belongs are those in katong before. Okay, less than 7. And then the bases higher 7. Okay, so if we have that one, now this is also the same to KB. When you have a large KB, then you have meaning the product is more favored, and then also your pH will be what? If we have a higher KB,
Mas
More
more than
than
7.
seven.
Base.
okay, yes, pH is more than 7 or
Seven.
pH is higher. Okay, so that's it. Now, what else? Okay. Now, okay, so if we have again, nasabi po ganyan, if we have weak acids and weak bases, then we will have a conjugate acid and then you have your conjugate bases. Then also the arrow is double-headed, whereas and also for strong acids, okay, strong acids is easier to compute because uh if we are given, okay, if we are given with the initial concentration of your strong acid, if you have concentration of 10 molar of your strong acid, then your the concentration of hydronium ion or the H plus also will be what? Will be 10 molar. Okay, it will also be 10 molar because again, it will dissociate completely. So if we have this one, again, if we have this one more specific, if we have HCl, you react that with water. Okay, so we will have H plus and then we have Cl minus, di ba? Okay, so if we have that one, and then if we have 10 molar here of HCl, because this one HCl is a strong acid, right? Now, when you react that with
Yes.
water, then it will dissociate completely. Then what will happen? All the all HCl, all the hydronium ions will be 10 molar, and then also we have also 10 molar of the Cl. So, have after doing this one, then we can easily calculate the pH. No, so the pH there, if we are asked what is the pH is just equal to the negative log of the concentration of your H plus or HCl. Okay, mo dissociate naman siya completely. Now, if you are asked of if we have acetic acid, sabi ng acetic acid class, ethyl aceto. Okay. All right. 1, 2, 3, 4. Okay. So if we have an acetic acid, okay, if we have the
Kuan.
CH3,
CH3.
CH3,
COOH.
okay, COOH. Now, if we
H.
have an acetic acid is weak or strong?
Strong.
Strong. Now, what's the difference? Or, okay, the difference there is just one. Or all, all acids that has carboxylic acids as functional group. If we have COOH, now if you see COOH, then it means that it's a weak acid. Okay, so it's a weak acid, then that will partially ionize. So meaning if we have 10 molar concentration of your acetic acid, then you react that with water, it will form H3O plus COO CH3 COO minus. No. Now, if that's the case, since this is a weak acid, then it will ionize partially. So at equilibrium, this is 10 molar, then your concentration of H3O plus is not 10 molar. So that's the time that we will use the ice table. Okay, that's the time that we will use the ice table. Because we cannot assume that ang imuhang H3O plus is just equal to the 10 molar concentration of your acetic acid. Now, kung strong acid siya, we will directly compute the pH. Now, we will use the pH is equal to negative log of 10 molar. But if we have a weak acid, then we will use the Ke values, katong taas-taas siya, the product over the reactant. Then, that is at equilibrium. So, that's why you use ice tables. Okay. Now, so here, let's go to ionic equilibria in aqueous solutions. So we have acid. Okay, we will talk about equilibria of acid base, the buffers, and then we will have also the acid base titration curves. Okay, so we will be dealing these two only. Okay, then we will add that one to the previous chapter, which is acid base. Okay, so buffers, when we have buffers, acid base buffers. Acid base buffer is a solution that lessens the impact of the pH from the addition of acid or base. Now, acid base buffers, when you search that one, buffers resist the pH change in pH. It resists the change. Resist the change in pH. Now, because uh, if you have a strong acid and then you add a base there, then of course the pH will change because the strong acid and then you add a base. So, ma-change yung pH. Now, what happens to buffer? But if you have a buffer, when you add any amount, when you add acid or a base, then the pH will just change slightly. Gamay ra iyahang ma-change sa pH. Mao na class, our blood has a pH of 7.5. Okay. Our blood has a pH of 7.5. Now, it has buffer on it because para inig magkuan, para just a small change of acid, just a small change of pH, dili din siya mo change diretso because it is buffered. Naa siya buffer. Okay, let's watch this one. Okay. So if we have this one, okay, this is your solution. Okay, you see this one? This is your solution and this is a pH meter. So, nani ni siya class? Nagamit mo pH meter katong nag-laboratory mo? Unsa the pH meter inyong gamit? Hello? Katong naglab mo.
Ma'am?
Ay, katong sa electrolysis.
Okay. Electrolysis. Okay. Now, katong nag-laboratory mo class on acid base, di ba? Acid base, nagamit ba mo ginani?
Wala, ma'am.
Unsa na to inyong gamit?
Bunsen burner, ma'am.
Anything nga katong Bunsen burner is just for heating. Like ano, litmus paper.
Yes, ma'am. Nagamit, ma'am.
Okay, litmus paper is an indicator if it is an acid or if it is a base. Yan, mo determine siya. What about indicators no, like phenolphthalein, methyl blue. Nagamit mo ato.
Yes, ma'am. Tong
Yes,
phenol.
ma'am.
Okay, all right. So those are indicators. They can detect if your solution is an acid or if it is a base. Now, this one is ano siya, uh, naka-ano siya, naka-connect siya, ano siya, kining pH meter. So it gives more accurate result. So we have that one. Kay muhatag jud siya pH value, di ba? Katong litmus paper, you can just say na acid siya. You can say base siya. But here, using this pH meter, you will know the value or how acidic is it? Is it 1.0? Is it 1.3? Okay. So yun na ni siya. This is a pH meter. Now, this is okay. You will just it has an electrode. Okay, this one. An electrode and then you just imura siyang imura siyang ibutang sa imong solution and then it will read. So, if we have unbuffered solution, it is 5.0. The pH is 5.0. Now, when you add that one, okay. Okay. Now, if you add HCl, okay. So if we have 5.0 ang imuhang solution, is it acidic or basic?
Acidic, ma'am.
Is it acidic, Emma?
Yes, ma'am.
Okay, it's acidic. Now, when you add HCl, so HCl, is it an acid or base?
Acid.
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 Okay, it's an acid. It's a strong acid. Now, what will happen if this is your solution and then you add more acid of it? What will happen?
Mugamay, ma'am. Ang
Mas
pH.
ma-acidic pag gyud siya ayo, di ba? Mas ma-acidic siya.
Yes,
Acidic
ma'am.
na siya and then gibutangan pag mo siya strong acid din, mas ma-acidic siya. That's why your pH became 2.0. It's more acidic. Okay. So that's it. Now, if this is your solution, again, what will happen if you add NaOH? What is NaOH?
Base.
Is it a strong one or weak?
Strong.
Strong. Okay, strong. Now, kanong again, basta determine, you review how to determine if a strong one or a weak one.
Weak na siya, ma'am.
Diba? Weak ni siya?
Oh. Ay, di ba, ma'am, kuan, ma'am. Strong, ma'am, kay Na, ma'am. Sodium, man.
Oh, metal and then you have an OH. Okay, metal and then OH, that's a strong acid base. Okay, so it's a strong base. Now, your solution, if you have this solution and then you add that to with NaOH, what will happen?
Kuda ko ang pH value.
Okay, it will become more basic. So that's why nahimo siyang 12.0. This is, again, this is unbuffered solution. No buffer. But if we have this solution, if you have this one, it has this solution is buffered. Okay, buffered. And then when you add that one with HCl, okay, you add that one with HCl, what happened to pH?
Yung
No,
gamay, ma'am.
nigamay siya. Yes, nigamay siya. Because this HCl is a strong acid. So, of course, maka-assume din tang, mugamay siya kay strong acid imong gi-add. Just like ganina, Migamay siya og pila ang pH nahimo. Nahimo siyang 2.0. But whereas here, ni gamay siya, however, it's just slight. Gamay ra iyang pH change. That is because it is buffered. Because your solution is buffered. When we have a buffered solution, remember, buffer resist pH change. So, para dili din siya mo change ang imuhang pH. Okay. Now, we have also here, we have, what if in your solution, your buffered solution, we add that one with NaOH? What happened to the pH? The pH increases. However, it's just very slight compared to this one, 12.0. Okay. So, uh, that's it. The pH resist buffers resist pH change. Why? Why does it resist pH change? Unsa man day na sa buffer? Now, remember, take note that, please read the second paragraph sentence. An acid base. Okay, please read Dailin.
Ma'am, white screen sa ko.
Nag-white
Screen
screen.
jud, ma'am.
White screen siya, ma'am.
Okay ka na.
Ikaduha to, ma'am.
Yes.
An acid-base buffer usually consists of a conjugate acid-base pair, where both species are present in appreciable quantities in solution.
Okay, so an acid. Okay, an acid-base buffer usually consists of conjugate acid in conjugate acid-base pair. Okay, so meaning, okay, we have a conjugate. Kung sa ganito makakuan og conjugate when we have a strong or weak?
Weak.
Okay, weak, because we cannot create conjugate acid-base pair if we have a strong acid or a strong base. Okay, we have that one. Acid-base buffer usually consists of conjugate acid-base pair where both species are present in appreciable quantities in solution. We have here green. Okay, so your buffer, this is your buffer. Makita ra?
Yes, ma'am.
Yes,
Yes,
ma'am.
makita ra.
Okay, so your buffer consists of, okay, it consists of your weak acid, and then we also have its conjugate.
Base.
Okay, good. Conjugate base. So that is your buffer. A buffer is consist of weak acid and then conjugate base, or weak base conjugate acid. Okay, now this one. So if we have that one, okay, if we have example, acetic acid, ano? CH3COOH. Okay, that is your acetic acid. It's a weak acid or weak base, or strong acid, strong base.
Weak
Weak.
acid.
Okay, it's a weak acid. Now, if we have that one, okay, pag ikuhanin mo siya sa water, when you react that, when water, it will ionize partially. Okay, double-headed arrow, then we will have CH3COOE, OO minus, plus H3O plus or the H plus. Now, this is a buffer. Okay, this is your buffer. It has a weak acid, okay, your WA, and then determine the conjugate base.
CH3COO minus.
Plus.
Wow, okay. So this is your conjugate base and then your conjugate acid. Okay.
Acid.
So we have that one. Now that is your buffer. Now uh, if we add NaOH to the solution, asa siya mo react class?
Sa base, ma'am.
Eh, sa NaOH is a
Sa
base.
acid.
Sa weak acid, ma'am.
Sa acid. Sa weak acid. Sa CH3COO.
Yes. Okay. So because of that, NaOH will react to this one conjugate acid class, not this one. So it will react to your conjugate acid, or if we have HCl, asa siya mo react class?
Conjugate base.
Okay, this one. So that's why the buffer can resist pH change, because either either you add a strong base, a strong acid, or a strong base, either of them, unsa imuhang i-add, then there will be a conjugate base or a conjugate acid to neutralize. Para mo neutralize sa siya. When we again neutralize, unsa ng neutralize? Sige na, neutralize class. Let's search.
Gamay rag change, ma'am.
Okay, neutralize. Okay, when we have,
Normalize.
all right, imuhang i-normalize. Okay, we have that one. Kita. Mani. Okay. All right. So either we add an a strong base or a strong acid, because it is buffered, then there will be a conjugate base or a conjugate acid that will neutralize. So mao na it will resist the pH. So gamay ra imuang pH change compared to unbuffered solutions. Then ano siya, if you have unbuffered solution, then example HCl, the solution is HCl, then it's unbuffered, then no conjugate acid or conjugate base that will neutralize. So that's it. Now, how to determine? Okay. Now we have this one. Please read. Acid base. Okay. Ano, sentence 3.
An
Okay,
acid-base
Krisa.
buffer. Oh.
O sige, Krisa, Aran.
An acid-base buffer is therefore a solution of weak acid and its conjugate base, or a weak base and its
Okay, so
conjugate
again,
acid.
that's your buffer. Your buffer is consist of weak acid and its conjugate base, or we have the weak base and then we have the conjugate acid. Okay. All right. Now, if we have this one. Okay. All right. So, we have number 1, determine. Okay. All right. Determine ano siya, if it is a buffer solution or not. Number 1. Again, buffers consist of weak acid or weak base and its conjugate. Okay. And its conjugate. Now we have this one. HNO3. Okay. Let's determine if this is a buffer or not. Ay. Yes, this one. Okay. Each and all three. Is it a strong? What is it? Unsa siya?
A strong acid.
Strong acid. What's the difference?
Two.
Two. Yes, we have three oxygen and then one hydrogen, so difference is two. Now, if you have two or more, then a difference, then that's a strong acid. Okay, what about this one, HCl?
Strong, ma'am.
Acid.
Is
Strong
it a
acid.
buffer solution or not?
Not, ma'am.
Okay,
Not.
not buffer.
Not.
All right, number two.
Strong acid, ma'am.
Acid.
Strong
Okay, sodium
acid.
Strong
nitrate.
acid.
Strong base, ma'am.
It's a
Strong base.
it's a conjugate. Yes,
Strong base.
it's the conjugate, diba? Conjugate base raman ni
I
siya.
can
NO3 when you react, cause class you can pwede man ninyo ni siya i-delete or i-X ninyo ang sodium because it's a spectator ion, meaning it's naa siya sa reaction but it does not participate. We know that naa lang siya dira but no, it does not participate. So we have that one. It's a spectator ion. We have sodium nitrate. So this is the conjugate base na siya. It's a conjugate base, 'di ba? And NO3 minus. But is it is it a buffer or not? Because HNO3,
not, ma'am.
when you react that with water, okay, it's a strong one. Strong man din eh. Okay. So it will become NO3 minus plus H3. Okay. So we have a strong acid and then the conjugate base. So it's not a buffer because it's a strong acid. Number three. Is it a buffer or not? HNO2, is it a strong
Buff.
acid or weak acid?
Weak
Acid,
acid.
ma'am.
Weak
Weak acid.
acid.
Yes, weak. Weak acid. Then we have NaCl.
Strong base.
Strong base. Na siya OH. Diba? Basta base. When you say base, na siya OH. Okay. It's not an acid nor a base. It's a salt. So this is not a buffer. Okay. What about number
Strong salt.
4? Okay. What about number 4?
Weak acid.
Then what about
Weak acid.
this one? This
Weak
one.
base.
It's the conjugate.
Conjugate base niya, ma'am.
Okay, it's the conjugate base. So we have HNO2. You react that with water. Then we will have H3O plus plus NO2 minus. So this one and again Na is a spectator ion. So sodium Na, that's sodium. So NO2 is your conjugate base. Now number 4, is it a buffer or not?
Buffer, ma'am.
Buffer.
Yes. Yes. That one
Shall I
is
check?
that one is a
Buffer.
buffer. Again, buffer is weak acid or weak base.
Weak
Then you
base.
have the conjugate acid or conjugate
Base.
base. Okay. We have that one. Okay. All right. Buffer. Okay. Again, buffer works through common ion effect because, you know, common ion because what you add there is common. Common na siya. If we have this one, if we have acetic acid, okay, then when we add acetate ion, so the acetate ion, okay, is ano siya, common. So that's why it's common ion effect. Right? Buffer works through common ion effect. Now, again, here, NaCl. This is the best example in this one, in this phrase, in this sentence. Buffer works through common ion effect. Now, HNO2, again, NaCl is not the common, okay? It's not the common ion with NO2. So that's why this is not a buffer. Now, if we have this one, number 4, HNO2. NO2 is common to the weak acid, so that's why it's common ion effect. Right. We have the common ion effect. What you add is just common to what is already there. Okay, so again, the dissociation, percent dissociation. Okay, percent dissociation is what dissociated and then what's the initial. Okay, di ba? When ayun lang jud mo kalimot class, when we have the present always works with the pila imong score. If you have the score, if you have the 7, then over the total, then you times it with 100, then that's your present score. Now here, if we have the percent dissociation, katong may dissociate, which is the X over the initial concentration times 100, initial times 100, then that will be your percent dissociation. Okay, so we have that one. All right. Now here, how a buffer works. Okay. If we have this one. Okay, so if we add this one, H3O plus. Okay. If we add H3O plus or an acid, diba, acid, this represents also with the base. Okay. Now, if we have an acid, okay, if we add more, okay, this one is your reaction, the violet or the purple one. The purple is your conjugate base. And then your orange mo ni siya imuhang weak acid. All right. Okay, so if we add more acid, so it will react with the conjugate base. If we add more acid, then it will react with the conjugate base. And then what will happen is we will have more of your CH3COOH. Okay, this one. All right. Now, but if we have, okay, they are the same. We have CH3COO minus, okay, it's the same. Now, this one also has a name, but it's another name. Okay, if we add more base, then the base will react with the weak acid. Okay, it will react here. Then we will have more of your conjugate base. Okay, so that's it. If we will add an acid, then it will react with the conjugate base. Then we will have more of weak acids. Now, if we have a weak base, if we will add more base, then it will react with your acid, and then we will have more of your conjugate base. All right. So we also have that one. Now, how do we calculate Ke? Again, Ke is just product over reactant. Then the pH is also the pH is just the negative log of your H3O plus times this one. Okay. Now we have that one. So the formula for the buffer, okay, is we will have this Henderson-Hasselbalch equation. Okay, this equation. Now, if we have a buffer, then how to calculate the pH? pH is just pKa plus the log of the conjugate base and then your acid. That's the concentration of your acid. 30. Okay, so this is your pH if we have a buffer. Now let's go here. Okay, don't forget the formula. Okay. Again, what's the formula? So, stay. pH is equal to pKa
CP,
plus, how do we calculate pKa?
Kuan, ma'am. Negative log of Ka, ma'am.
Negative log of Ka. All right. Now, plus, okay, no question with this. Delete na to. Okay, plus log of the base or the conjugate base over the
over acid.
Acid.
acid. That's the concentration class. Concentration. Okay. All right. Now, if we have this problem, huy. Okay, if we have this problem, please read. Okay. Calculate. Okay, if we have letter A. Okay, please read. We have ano, generous. Ay,
Of a buffer solution consisting of 0.50 molar sa galing
Acetic acid.
acetic acid and 0.50 molar of ano isa?
of
CH3COO
sodium acetate
of a buffer solution consisting of 0.50 molar
Okay, so we have that one. It consists of okay, CH3COOH. Okay, it's a weak acid and then the conjugate base. Okay, we have this one, the CB. All right. Okay, so we have this one. Now, how do we calculate this one? A buffer solution consisting of 0.50 molar. Again, so let's use this one. So we have, okay, we are going to calculate the pH. pH is equal to pKa. What's the value of pKa? Is Ka given? Number one in letter A. Now, Ka is not given, but Ka is equal to 1.8 times 10 to the negative 5. That's Ka for acetic acid. Okay, we have that one, Ka. So we will use that one point is equal to pKa man siya class. So ato na lang siya in negative log. pKa is equal to negative log of Ka is equal to negative log of 1.8 times 10 to the negative 5. So what is pKa? Calculate daw. Negative 1.8 times 10. Pila class? Pila siya? Calcio. O may calcio class? Hello?
0.74, ma'am.
We have
4.74.
4.74. Yes, 4.74. Okay, so let's plug in the value. We have 4.74 plus log of concentration of the base. What's the conjugate base here?
Sodium acetate,
Si
0.50 molar.
Okay, 0.50 molar. We have, okay, isulat sa po nato next time. Dili kaning base na to isulat. Next time, we will write, ano jud, the conjugate base. We have sodium CH3COO. Then, also, the acid is CH3COOH. Okay, so we have that one. Okay, what is the concentration of your base? That's 0.50 molar
molar.
over 0.50 molar gihapon.
Yes,
All
ma'am.
right. All right. Okay, so the pH is pH is log of 0.50, we have 0.50 over 0.50, that's 1. Log of 1, that's 0. So we have pH is equal to 4.70.
24.
Okay, so that's your pH of your buffer. Okay, now what about letter B? Now, we have letter B. After adding 0.20 mole of solid NaOH to 1.0 liter of the buffer solution. So we add, pila tong gi-add?
0.020 mole.
Mole. That's mole. Now
Yes,
again,
ma'am.
yes, we know that we have here is concentration, mole per liters. So we will use 1. Okay, so what's the concentration of your sodium hydroxide?
0.20 moles per liter, ma'am.
Okay, that's
0.020.
yes. How did you get that one?
Divide after
0.020 divide 1.0. Okay, so we have that to 1. Okay, so pH is equal to pKa plus log of, okay, we have CH3COONA over the concentration of CH3COOH. Okay, now we have that one. Okay, so let's use this table. before addition, then you add, and then we have after addition. Okay, this, right, we have another table here. So we have, okay, we have CH3, COOH plus, you add NeOH. Okay, so we will use the OH there. You add that one. So we will have here is, we have CH3COO minus plus H2O. No? Plus H2O. Nagets ang equation, class? Okay. Nagets ang equation? This
Yes,
one.
ma'am. Yes,
Okay,
ma'am.
because we have acetic acid and then we have OH. Now, the OH, asa gikan ng OH?
Sa
Sa?
sa solid na sodium hydroxide, ma'am.
Okay, this one. Gikan siya sa NaOH now. Alright. We have initial. Okay, so we have before we add, initially, ang atoang solution, atong concentration sa atong acetic acid is pila to? This one. 0.50. So we have 0.50 molar. Then, okay, before pa man ta nag-add, we have 0 also here. And then we also have here 0.50. Diba? From here. Okay, 0.50. And then, then you add, what do you add? You add
0.20.
0.020.
0.020.
We have that one, 0.020. So, what will happen is 0.020 mole of OH will react to CH3COOH. So, after addition, we will have, okay, this one will be minus 0.020. Okay. This is addition. All right. Kailan ako butang. Okay. Now, all right, we have that one. We have 0.020 moles of OH. Now, when we add more of the concentration of your hydroxide ion, then it will react with CH3COOH, right?
Yes, ma'am.
Okay, so it will react. Then, after addition, then you will have 0.50 molar times you react that one with OH. So we have minus 0.020. So after addition, you will have 0.48 molar of your 0.48 siya.
Yes, ma'am.
All right. And then also, because after addition, now after addition of 0.020, we know that since this is reactant, so ma-minus siya, diba? Because it will be consumed, forming into product. So what will happen? So 0.020 minus 0.020, so we will have 0 after addition. Okay, after addition of 0.020 hydroxide, then you will have 0 of it because ma-consume siya, forming into a product. Now, what will happen here with your conjugate base? Mahimo siyang 0.50. What will happen? Because you add 0.20, it's in a product. So, add siya of 0.020. Follow pa, class? Now, remember, go back to your kinetics na ang reactant ma-consume, ang product ma-form. Ang reactant mo gamay, ang product mahimong mudaghan plus 0.020. So, after addition, we will have how much of your CH3COO? Ion. We will have plus 0.50.
0.078. Ay, sana? 20 ni?
0.70.
70? Asa man lagi tayo?
0.70.
0.52.
0.52.
Ay, okay. All right. 0. We add 0 plus 0.020. 0.020.
So 0.0.
0.70 lagi no.
0.52.
0.52.
0.72.
Okay, 0.52. Again, all right, ha? We have this table. This is not an ice table. Ano lang siya, gibuhat na to siya para makita na to ang stoichiometric relationship. We have this one. So before of the addition, your initial concentration is just 0.50 of your acid, and then you are conjugate base 0.50. Now, you add 0.020. Okay, if we have that one plus, murag ano ba? Giada ni mo siya og 0.020. So, your buffer na gali, then you add more of 0.20. So, the OH, we know your in OH, since it's a base, it will react to your acid. So, we have that one. So, your acid will become less. Your uric acid will become less. And then your OH will be consumed. So, that's why it became 0. And then your CH3COO minus will become more of it. So, that's why may mo siyang plusan. Because it's a product. Kato na lang atong balikan. When we have a product, then ma-plus iyang concentration. So, we have 0.52. Okay, we have that concentration. Now, let's go to pH. pH. Okay, so pKa. What is pKa again? pKa is
4.74.
4.74.
4.74 plus log of. Okay, CH3COONA. What's the concentration?
Ano to 0.0?
0.52.
52 mol.
Okay, 0.52. Now, ayaw mo ka-confuse class if we have an NA and then you have just a minus. All right. So, NA is just an spectator. So, it is there but it does not participate. We have there what? This one. CH3COONA, we have
0.52.
other books, instead of log of base over acid, they use log of salt over the acid. Why salt? Because this CH3COO and then this with your Na, that's a salt. That is a salt. So that's why they use salt over acid instead of conjugate base over the acid. So, parehara siya class. Ang uban lang kay ginagamit nila is salt, then ang uban pod conjugate base over conjugate acid. It's a salt, gamit nila salt because of the Na. That's a salt. Na and then this one, the acid, so that's the salt. Okay, we have that one. 0.52, then we have CH3COOH. Pila to yung concentration? 0.40 class.
0.48 no.
48.
Okay, so we have that one. Equals, pila? pH is equal to pH is equal to pila ni class log of 0.52. 0.52 plus I divided by 0.48 log of ans 0. Ano no? This one is
0.2, ma'am.
0.347. So you add that one, that will become plus 4.74. So that's 4. pH is equal to 4.77. Log of this one, it's 0.0347 man. Then you add 4.74. So kuha, pH is equal to 4.77. Okay? Hala.
Yes, ma'am.
Sige daw.
4.77.
Okay.
Yes, mommy.
All right. So very good. Now notice that the pH or the change in pH is just very 0.74. Now it's just very small. Now you can also check your answer because you add more of base class, you add more of base. What will happen to the pH? pH will
Mudako.
mudako. Okay. You see that one? Alright. Nidako siya because gaad ka og more base. So that's why nidako siya 4.77. It's less acidic compared to this one. Okay, so what about if we add we add 0.20 mole of HCl? Okay, instead, now if we have this one, imong i-assume sa imong pH, less or mugamay? Mudako or mugamay? You add an acid.
Mukamay, ma'am.
Tamay, ma'am.
Mas acidic siya no, mugamay imong pH. So let's go down. All right. So again, we will use the B after addition, then after addition. So we have CH3. Wait. Okay, we have that one, CH3, COOH. Then you add an acid. Okay. All right. Okay, since you add an acid, this one will be minus. Okay, so atong baliktadon class because we know that an acid reacts to the conjugate base, the HCl or the H plus. Then we have what will happen here is we will get H or CH3, COOH, then plus the OH minus, right? The OH minus came from from water. Okay, from water, so we will have the OH minus. Okay, so since we have an HCl, since we added an HCl, so meaning we added more of H3O plus or H plus. Okay. All right, so what will happen here is we have CH3COO minus, the initial concentration of this one is 0.50 molar. Then this one, before you add something, this is 0.50 molar. Then you add HCl, you add 0. Pila to? 20, no?
Yes, ma'am.
0.20. So after addition, this will become
0.50 molar minus
okay, that's 0.48. Then we have the 0. Okay, makonsume man ni siya. Then we have also this one. Mahimo siyang
0.52.
0.50.
alright. Okay, now let's pH is equal to pKa plus log of CH3COO minus over CH3COOH. Then, pKa is equal to 4.74 man to ganina plus log of, sige, COO minus, that is
0.48. Mm.
okay, this will become pH is equal to
4.71.
that is 4.71.
71.
Okay, so we can check that noon sa pH, it's 4.74.
Gamay.
Gamay. Yes,
Gamay siya.
because we are adding acids. So, ang acid, mas magamay, mas acidic. Alright. Okay. Yay.
Saksong assumption.
Okay. Alright. Now, ano na lang class, if you don't want to create this one, this table, okay, before you add something, then you add, then after addition, what happened? If you don't want to make this one, ano lang, if you have an acid, okay, if you are given with an acid, when you add an acid, asa siya mo react? Dito sa imuhang base. Okay, dito siya mo react sa imuhang base. Now, what will happen if mo react siya sa imuhang base? Dito siya mo react sa base. So, mugamay ang imuhang base, no? Mugamay because it will be consumed. And then, okay, we have this one. pH is equal to pKa plus log of base over the acid. Okay, if we add an acid, if we add an acid, mo react siya sa base. Then, what will happen to the base? Ma-minus siya, no? Mugamay iyahang concentration. And then, what will happen to acid? It will become more. So, mahitabo, that is log of, if we add 0.30, then if we have 0.80 of base, and then if we have 0.90 of your acid, so what will happen is 0.30, you minus that one with your base because it will react. So we have 0.50 divided by, then what will happen to the acid? It will become, what will be the concentration? So 0.90 plus plus 0.30. That is equal to 1. Pila class? 0.2. Okay. So inana lang, if you don't want to make if you don't want to create the table, okay, if you don't want to create the table, then you can inani lang. Okay. If you don't want to create a table, again, if you have an acid, then it will react to the base. Now, kung react siya sa base, then it will be consumed. That's why you minus. Now, if Okay, if you add an acid, it will react to the base. That's why minus, because it will be consumed. And then what will happen to the acid? It will form. It will form. So that's why U plus 0.90 plus 0.30. That's why we have 1.2. If you don't want. Okay. Okay na class? Question daw.
None, ma'am.
Okay, Jenny Rose, question. Ma'am, nalibog ko, ma'am. Nalibog
Ma'am.
ka? Ha? Okay, ha? Alright, if I have this one, what will be the pH? Calculate the pH of... Unsa na po? Hindi na po acetic acid. Kato to mga
Hydrochloric acid.
previous. Hydrochloric acid. That's strong. That cannot be a buffer.
Hydrofluoric acid.
HF. Sige, HF. Alright, we have it HF. It's a weak acid, no? HF. Plus. Okay, if we have an HF, then also, what will be the conjugate base?
Fluorine ions.
Okay, we will have H through O plus plus F minus. Okay, now we have that one. Okay, so what will be the initial concentration? Suppose we have 0. I know 0.30 molar. Okay, your concentration of your HF. What about F? What will be the concentration of your F minus?
0.20.
0.30.
We have 0. Unsa?
30.
30.
30? Kanalahi daw.
20, ma'am.
15.
20, ma'am.
20.
20.
Okay. Now, class, all right, let's talk about here the buffer, ano siya, effectiveness. Okay, murag, unsa man ang unsa ang kaning mas nindot og effect nga buffer. So, mas nindot og effect nga buffer if the concentration of your weak acid is equal to the concentration of your of your conjugate base. So, mao na siya effective kay imong buffer, meaning it can resist pH. So if there will be a slight changes in pH only. So that's why here, when going back, when here kani atong problem, we have 0.50 of the weak acid, and then we have the 0.50 of your conjugate base. So it has the same. That's why the pH change, the difference in pH is ano ra kay siya, is very small. So like this one, 4.77. 4.77, and this one 4.74. So gagmay kay siya iyahang pH change only. Gagmate kayo because your buffer is very effective. It's very effective because, again, the concentration is ano siya, just the same. Now here, if we have this one, okay, if we have this buffer, guess naman to. If we have this buffer na 0.20 and then 0.30, then ano siya, makita natin siya nga, ano, there will be, ano, higher ihang pH change. Pero sige lang, go. Let's go here. We have 0.20.
Laban.
Okay. Laban. So pH is equal to, okay, what's the Ke of HF? Okay. 6.6. We have 6.6 times 10 to the negative 4.
That's -4.
Okay. So pH, All right. Ka of HF is equal to 6.6 times 10 to the negative 4. Okay, so pKa plus log of base over acid. Okay, so pKa is equal to
6.6 times 10 raised to negative 4.
pKa man. This is Ka.
Ay,
How do we get
log.
pKa? Negative log. Go.
Yeah.
Sige daw.
Three 3.18.
3.18
Yes, ma'am.
plus. Okay, what about the base? Okay, so we have the base is
0.
20
0.
over the acid
0.30.
0.30. What will be the pH? Pila siya? pH is
3.
3?
Yes, ma'am.
Why sobra? 0.20
Wala.
divided by 0.30
3.003.
log of ons. Ay,
3.003, ma'am.
okay. We have 3.003. Okay, sige ka na lang
Ay,
sa. Alright, we have that pH. Now, what will happen?
excuse me, ma'am.
Okay. Yes.
Ma-4 na rin na siya, ma'am. Kaya ang tapad ni 3 kay na.
3.004.
Okay. All right, what will happen if okay, so that's the pH, no? If we don't add something. Okay. Now, what if we will add? Okay, what if we will add ano 0. Ano 60 mole of 1 liter of NaOH. So what will happen? Asa mo react ang NaOH? That's a base.
Sa,
Acid.
sa H2O, ma'am. Ay, sa acid, ma'am.
Sa HF. Okay, sa HF. All right, so we have that one. pH is equal to pKa plus log of base over the acid. Okay, so pKa is pila to?
3.004.
3.18. pKa man plus log of.
Oh, yeah.
Okay, what happened? Okay, we add tuwilaga ito itong gi-add, we add 0.60 mole of
1 liter.
1.5 liters. 1.5
Sure.
liters of NaOH. How do we calculate? How do we convert that
0.6 molar, ma'am.
How do we convert that
1.5.
into concentration, moles per liter? 0.60 moles divided by 1.5 liters. That will become
4.
0.6.
0.4. 0.4 molar. Moles per liter na siya, no? Okay. Don't forget, class nga, you have to convert that into ano jud, molar. Okay. Now, but if given na jud kag inani 0.4 molar, big M na ang gihatag sa imo, then no problem. Okay, that will be easy. So we have NaOH. Now, NaOH will react to the acid because it's a strong base. Now, okay, so it will react to the acid. Now, kung mo react siya sa acid, may maunsa ang concentration sa imong acid.
Mataas. I mean, mo
Ma-consume.
increase mo that.
At least,
Consume.
ako din.
Okay, makonsume. Makonsume. You react that one. Plus, you react
Ma-consume.
NaOH and then an acid. What will happen? It will be consumed. Okay, so we have mugamay siya. We have your acid is 0.30. Nadakuha pod kay sa atong kuan eh. Okay, this one na class B. Nang lapas naman, we have this one. 30 na lang. 30 divided by kani. Pila ni class?
0.2, ma'am. Molar.
Ay, gamayan pa jud nato. Okay, gamay na po datong isa. 0.10 na lang ni B. 10. Okay. Then what will happen? Pila ka molar class?
0.01. Oh.
0.01. Okay, so you will have 0.01 molar. Okay.
Tanong yung gamay niya.
Gamay na kayo. Sige lang, gagmay man gud atong pagsugod na concentration. Okay, we have that one. Okay, so we have 0.01. So what will happen to the acid? Because in EOH will
Ma-consume.
react. Okay, mugamay na lang. Makonsume siya, pero
Sige,
mugamay
mo
lang.
decrease.
Okay, we have that one, decrease. Okay. What's that one first? 0.30. So 0.30 minus 0.01.
0.01.
That will become
0.29.
29. 0.29.
0.29. Okay, 0.29. Then, what will happen to the base? It will form. Conjugate base, it will
Dako,
form.
ma'am.
So, it will become 0.20.
Yeah.
Okay. So,
1.
pH is equal to may kayo. Marsag wala. Kay gagmay kay tong kuan. Pila pH class?
3.04.
3.04 gihapon?
Yes, ma'am. Ay, pero mas dako-dako lang siya kasa isa.
Mas dako di siya, no? Sige. Yes, because
Yes,
this
ma'am.
is, giada ni mo siya og base. Mudako siya. Pero gamay ra kayo siya gyud kay because ano mo gud maglista tagad siya sa gamay kaya itong sugod nga concentration. Okay, pero ano lang siya class. Instead of working on the table, the bar table, you can do this one. We know that the base nga imong gi-add, it will react to the acid. And then if it will react, then it will be the concentration will decrease, and then your base will or your product will increase. So, mo na siya.
Excuse me, ma'am.
Yes,
3.04 man, ma'am. 3.04. Ang sa
3.0.
4.
3.04. Ang last pila.
3.004.
Ay, mas dako siya.
Yes,
Napila
ma'am.
siya change. Yay. Okay. Alright. So, na-notice class, gamay ra kay imong gi-add na concentration. Gamay ra kay imong kuan, mo change gyud siya. Buffered na ni siya. Okay. Now, notice that the change also is dako, no? Dako iyang change, 3.04 and 3.04. Because your buffer is, di ka siya effective. Because,
Yes, ma'am.
again, your buffer can be effective if your HF and your F minus is almost equal or even equal. Dila sila mas effective kayo. So, if equal siya, then the change in pH will be Basin maana ra pod ni siya 3.007. Now, because it's not ano siya less effective mo ng 3.04. Okay, so that's it. So dira sa tataman class the pH, your buffer, and then also
Excuse me, ma'am.
yes,
What if, kuan ma'am, mas dako ang, kuan ma'am, ang buffer, ay mas dako ang conjugate base, ma'am, kontra sa weak acid.
conjugate unsa?
Mas
Conjugate
dako ang
base.
concentration sa conjugate base kontra sa weak acid.
Mas dako ni siya?
Yes,
Sige
ma'am.
daw, try daw na to. Okay, if we have 0.70 divided by 0.40. Unsay mo question? Okay, unsay mong kuan ato Kyle?
Ma'am,
If dako
if,
siya unsa man mas effective ba or less effective?
yes, yes, ma'am. Effective siya,
Oh,
ma'am, or less effective?
less effective.
Okay,
Basta
ma'am. Basta
mas
dool ra gyud sa
effective. Oh, yes,
equal, ma'am.
they are close sa ilang concentration. But still, even if dako imo conjugate base or if dako imo conjugate base or dako imong acid, then it will still have a pH. Makalculate ra gihapon nimo. Pero in this case, kanimong gitan-aw, in this case, we have higher concentration sa imong acid and then you have lower concentration of your
Yes,
base.
ma'am. Kana, ma'am.
Okay, so less effective siya. Yeah, the same thing gihapon, less effective. And then, also, you still can calculate the pH.
Thank you, ma'am.
Okay, that's for buffer. Then next Wednesday, let's calculate acid-base titration. Then, exam na din ta. Acid-base titration.
Excuse me, ma'am.
Okay.
Na,
Alright, dili na din ta.
nakahatag ka aning kuan, ma'am, tapika?
Wala pa.
I mean,
Karon
sa
ako
power
i-send
PPT.
ha.
Okay,
Oh,
ma'am.
i-send ako. Oh. Alright. So, dira. Acid base. Again, class, when you have a strong acid, strong base, ano siya, easy ra ang pag-compute sa pH, no? Kay ang pH, is just equal to the concentration sa imuhang strong acid. So, kay maka-assume man ka nga ang imong HCl, again, balik na. Again, class, if you have HCl, then it will dissociate into H plus, and then you have, yung OH. Again, if you have 10 molar of this HCl, then you are asked of the pH, then diretso lang, negative log of concentration of H. Diba, negative pH is negative log of H plus or hydronium ion H3O plus concentration. However, this is a strong acid. We know that when it dissociates completely or it ionizes completely. So if you have 10 molar, then the 10 molar will form H3O plus also. So that's why we can use 10 molar. The negative log. Now, so the pH will be, kinada yun, negative log of 10. Pila siya? 10, negative log.
-1.
-1? Okay, so it's very strong. Okay, very strong. So we have that one.
Strong.
Now, if we have a weak acid or weak base, dili na to na siya pwede i-assume. Di ta pwede nga og tagaan ta anig acetic acid nga 10 molar. 10 molar. Di ta maka-assume dayon na H plus nimo kay 10 molar dayon, then mo gamit din kag pH is equal to negative log of 10 molar. No. Because this is a weak acid. So it dissociates or it ionizes partially, meaning the ang 10 molar nimo di na siya mahimong 10 molar H plus. So mao pa galit na mo kuan galit tag mo X galit ta, di ba? And sometimes the X we neglect because it's very small. Gamay kaayo. So by that, di ta mo assume diretso og 10 molar, but we assume it to be X. We let it to be X. It's very small. So that's why we use ice table. Now, also, okay, nato siya. Kung weak ra siya. Now, again, if you have a strong acid, strong base, no conjugate. No conjugate. Again, buffer is just a weak acid or weak base, then the conjugate. Okay. So that's all for today. Okay.
Mag-review pa ka sa exam, ma'am.
Mag-review. Oh, charot. Wala pa ko sure class kay kay napatay next topic ani magkuan pa ta. Thermodynamics.
Pero
Katong exothermic.
sige ma'am.
Last
Unsay
na siya, ma'am, na topic.
Pero na kay kuan ma'am sked para sa exam ma'am.
Kano sa man ta mag-exam?
Kana kung dili kay FEK ma'am.
Okay. Mag-titration sa tabi gigutom na mo.
Friday, mag-lab ang punta, ma'am, no?
Oh, yes, mag-lab mo. Pero different na siya. Types of chemical reaction ng Japon. Okay. Alright.
Mga yun,
Na
may na sa kuan ma'am, video ma'am.
Pila na ka-video, wala na ako na-send.
Ikaduha
Na-send
naman
naman siguro.
Katong last, ma'am, wala ka kasend.
Oo.
Wa ako ka-send ato. Sige.
Opo,
Alright,
ma'am.
gigotom na mo.
Ma'am, maghikay para ba ka?
Magluto pa gid ma'am.
Luto pa po mo, ma'am.
Ma'am, wala pa'y kanon kay maghikay pa.
Sige. Kay mag-klase pa po niya. Alright, so acid-base titration. Okay, so please read. Sige na ay. Alright. Okay, so that's all for today.
Pick up the pieces of paper under your chair. I missed
Okay.
that line.
Basin there,
Okay,
next time na.
Daghan magukay yung mga scratch ma'am kay gikuha na sa mga equation mo nang papunit.
Ang katong mga equation ninyo, pang-memorize na to, the pH plus POH. Diba? Pila pH plus POH, be? pH plus POH is equal to? No, wala pa nag-review.
Wala pa, Jude.
Wala pa dyan, ma'am.
Wala pa gyud ma'am.
pH plus POH equals 14.
14.
Oh, kana ha. Then kato mga KW, autoionization. Autoionization. So that's all. Okay, so that's all for today's class. Have a great day. Bye-bye.
Thank you ma'am.
Okay,
Ma'am, thank you.
Thank you, ma'am.
Ay,
Nagpapit tayo
ma'am.
mga topics.
Miskis ko ma'am. Mga yun mi sa kuan ma'am, mga total coverage ma'am kay para mag-advance mi sa uban ma'am.
Wow, mag-advance ang inyong kuan. Kay katulad kanina mga acid base and then the buffer and then let's go to acid base titration. That's the last topic. Acid base equilibria.
Okay ma'am.
Katong kani apil ni siya sa coverage para magkuan na din ta thermodynamics katong endothermic and exothermic reactions. Sayo na to siya. Di na kayo magkuan og equilibrium. Ay nagyapon. Then also electrochem. That's the last one. Duha na lang ka topics class. Bye-bye. Kaya pa
Bye,
natin
ma'am.
Di ba December
Laban.
pa man mag-end? December 3rd week?
Next year, ma'am.
Ha?
Yes, ma'am.
January pa.
December
December.
Unsa
15 or
December
16.
Bye, ma'am.
15?
Thank you.
December 15 finals.
Oo, ma'am. Ito.
Ma'am.
Din isa na natin electrothermo.
Grabe po dong next year. Eh, wala tayo Christmas break.
Walo lagi no.
December 15 to
More
16.
malagi dito.
Sige, dira na ta. Electro na lang og thermo atong klase. Electrochem ug thermodynamics. That's all. Okay. Bye-bye.
Bye-bye, ma'am.
Thank you so
Ay,
much.